This is a presentation about Newton's sums by Marcus and
Redon. So what are Newton's sums?
Newton's sums are formulas used in algebra and higher math to connect polynomial roots and coefficients.
They help find sums of roots and powers of roots without solving the entire equation.
The method simplifies complicated polynomial calculations. It is also called Newton's identities.
Important fact about Newton's sum.
Newton's sums make solving polynomial equations easier and faster.
They help find information about roots without solving the whole equation.
These formulas are useful in algebra advanced math topics.
Useful for IMO and USAGMO. IMO stands for the International Math Olympiad, and USAMO stands for the United States Math Olympiad, and the J adds the junior.
Newton's sums are used in real-life fields like engineering and science and economics.
Vocabulary to know.
Polynomial, an algebraic expression containing variables and exponents.
Root/0, a value that makes the polynomial equal to 0.
Coefficient, the number that is raised by a variable.
Power sum, the sum of roots raised to a certain power.
Symmetric expression, an expression unchanged where roots are rearranged.
The formula.
Consider the polynomial p of x of degree n. As shown on screen, this is the polynomial. Let p of x equals 0 and have roots x1, x2, all the way to xn. Define the sum p of k as x1 to the power of k plus x2 to the power of k all the way down to xn to the power of k.
Newton's sums tell us that an times p1 plus an minus 1 equals 0. An p2 plus an minus 1 p1 plus 2 an minus 2 equals 0. An p3 plus an minus 1 p2 plus an minus 2 p1 plus 3 an minus 3 equals 0, and so on. And basically, if the degree of the polynomial is lower than what you're trying to find, for example, you have a quadratic and you're trying to find the sums of the roots squared, then you would discard the coefficient at the end, and you'd only go up until the a which you have. And the general formula would be an pk plus an minus 1 pk minus 1 plus an minus k plus 1 p1 plus k times an minus k equals 0. And define a 0 equals 0 for j is less than 0. How to use Newton's sums.
Identify the coefficients A2, start with S1, then use it to find S2, then S3, and continue away. Apply the formula iteratively until you reach the desired power.
Finding the sum of roots using Newton's sums.
So the equation is 3x cubed plus 10x squared plus 8x plus 15. And so this means A0 is 3, A1 is 10, A2 is 8, and A3 is 15. If we have the roots be x, y, and z, S1 equals x plus y plus z, S2 equals x squared plus y squared plus z squared, and S3 equals x cubed plus y cubed plus z cubed. These are like the three equations we want to solve.
And then basically, like, you can substitute it into the formula, which is that 3s1 plus a1 equals 0. 3s1, substituting 3s1 plus 10 equals 0. 3s1 equals negative 10, and then s1 equals negative 10 over. This is the same equation.
3x cubed plus 10x squared plus 8x plus 15. Since we know from Newton's sums, 3 times s squared, s2 plus a1 times s1 plus 2 times a2 equals 0. 3 times s2 plus 10 times negative 10 over 3 plus 2 times 8 equals 0.
That's just substituting like the values into the equation.
And then 3s2 equals 52 over 3. And the s2 equals 52 over 9.
This is for finding the sum of the cube roots. So 3s3 plus s2a1 plus s1a2 plus 3a3 equals 0, as shown before, like in our formula. So 3s3 plus 52 over 9 times 10 plus negative 10 over 3 times 8 plus 3 times 15 equals 0.
So
then combining terms.
3 times s3 plus 685 over 9 equals 0. So 3 times S3 equals negative 689 over 0. And dividing both sides by 3, we get negative 685 over 27. Real life applications.
Engineering used to study vibrations in bridges, machines, and buildings helps engineers predict stability and safety.
Computer science, applied in coding theory and cryptography, helps improve algorithms and data processing. Physics, using wave motion and energy equation, helps analyze sound, light, and motion system. Economics, using financial forecasting and market analysis. Using Newton's laws in an engineering situation, also a word problem. A suspension bridge is being tested for vibration safety. The bridge's natural vibration frequencies are modeled by polynomial x cubed minus 12x squared plus 44x minus 48 equals 0, where the roots of R1, R2, and R3 represent the vibration frequencies. Engineers need to find R1 squared plus R2 squared plus R3 squared without solving for the roots themselves.
Here's the solution for the previous problem. Using Newton's sums, we get S1 plus A1 equals 0, S1 plus negative 12 equals 0. This is just substituting in the values. S1 equals 12, S2 plus A1, S1 plus 2A2 equals 0. S2 plus negative 12 times 12 plus 2 times 44 equals 0. Combining like terms, you get S2 equals 56.
This result helps engineers estimate the bridge's total vibrations, energy, and evaluate structural. Word problem number 2, economics. A financial analyst studies the annual returns of 3 market sectors. These returns, R1, R2, and R3, are all roots of the equation x cubed minus 9x squared plus 26x minus 24 equals 0. Rather than solving for them separately, the analyst uses Newton's sums to evaluate the total market performance. What is R1 cubed plus R2 cubed plus R3?
Okay, so to solve this equation, to get S1, S1 plus A1 equals 0. Substituting S1 plus negative 9 equals 0. S1 minus 9 equals 0, and S1 equals 9. Now we can use that to substitute into S2. S2 plus S1 A1 plus 2A2 equals 0. S2 plus 9 times negative 9 plus 2 times 26 equals 0. Combining like terms, S2 minus 29 equals 0, and S2 equals 29. For the cubes, S3 equals S3 plus S2A1 plus S1A2 plus 3A3 equals 0. S3 plus 29 times negative 9 plus 9 times 26 plus 3 times negative 24 equals 0. S3 minus 99 equals 0. S3 equals 99.
Thank you so much for being a supportive audience.
感谢你们作为支持性的观众。